Hi, good day. In this section, I will be discussing hybrid functions. Hybrid functions are mixed functions which have different rules for different parts of. We will sketch the following hybrid function and also calculate the domain and range for this function. Copy this function down on a piece of paper so you have it in front of you the whole time. As you can see, we have three different functions or rules, and we have three different domains. I will sketch function 1 first. Okay, from this function we can see that the gradient is 1 and the y-intercept is -2. This is how the graph will look, but remember, I haven't done the domain yet. Now remember, the domain is x must be less than -2. Let's see how this changed the graph. This is the graph with the domain x less than -2. Also, just see that this is an open circle, and that means that -2 is not included, which comes from this section here. Now we will sketch function 2, which is a parallelogram, and I will include the domain at the same time. As you can see, this is the graph, and we have the domain from -2 and +2. It's not an open circle anymore, it's one that's colored in, and that's because the x can be equal to -2 and 2. Now let's get function 3, which is a straight line, gradient 1 and y-intercept +2, and the x must be greater than 2. Okay, this is how the graph will look, and remember, it starts with an open circle. I will now put the three graphs together, and that will be your hybrid function. And this is our hybrid function. As you can see, we have our three different graphs, the straight line here, parallelogram there, and a straight line up here. Hopefully at the end of this section you can see that that's a smiley face, and you'll be smiling as well. Now let's have a look at the domain and the range. The domain is pretty easy because it was given to you in the graph when we started. You just have to put it all together. As you can see, the domain is the x values that will satisfy the functions. Now if you look at the x values, for every x value there is a y value, and when we get to the one where there's an open circle, well, if x is equal to 2, although it's excluded in this function, it actually is part of this function, so I will get a value there when x is equal to 2, y is equal to 0. The range is along the y-axis, and we can see that if we start at -infinity, we'll follow this graph, and then when we get up here at 5, we follow that graph, but then there is no values from here to there. There's a big jump, and then we follow that graph again. So that means that here is a gap where there's no y values, and that has to be reflected in our domain. Just to make sure that you get that, I've put this down at the bottom of the graph. Between 0 and 4 there is no graph, so that must be reflected in our range. Therefore the range in interval notation is given by this open brackets, which means does not include infinity, because we can't have a definite value for infinity. It goes up to 0, 0 is included, that comes from these dots, that's there. And then we have the union of 4, which is open brackets, because of that circle, up to infinity positive, which is like that again. Now let's evaluate f of -3. Now what does it mean? It means that we have to look at -3 on the x values, see which graph or function it relates to, and then substitute x -3 into that function. As you can see, if x is -3, we go down, meet this function, therefore the y value is -5. How do I calculate this? There we can see that I've substituted -3 in the place of x in this function, and I get an answer of -5. Now let's evaluate when x is equal to 4. When x is equal to 4, we go up and we meet this function, and we calculate it the same way. There's my calculation. I hope you have enjoyed and understand hybrid functions. Thank you.